Welcome to talks by members of the Survey and Cartography section of the National Speleological Society. These videos are intended to be how-to videos on cave survey software and other programs used by cavers in the exploration and documentation of the world beneath our feet. This is a session on georeferencing cave maps and survey data presented to the members of the Survey and Cartography section of National Speleological Society. Two software packages that we're going to be discussing in detail tonight are QGIS, Quantum GIS, and ArcGIS Pro. All the how-tos will be in relation to one or both of those packages. However, before we can really get started on diving into the button clicking in the software, one of the things that we really need to have is a common language to talk about georeferencing and make sure that we're all on the same page with terms and methods that are used commonly in the practice of georeferencing within GIS software. So I put together just a handful of slides here to make sure that we're in the same neighborhood on these topics. The first is just a reiteration of the topics that we're going to talk about tonight. I'm not going to read them all, but these are the kinds of things that people usually want to do when they're georeferencing. Just very broadly, I think three areas that we can hit on tonight are the idea of georegistering or registering as cave sketch, something out of a survey book, onto a line plot. So we'll talk about that. Another main task that people want to do is to register old cave maps. You know, maybe I went out and got a GPS location on an old cave or something that was mapped in the 60s and 70s, and I want to put that on GIS now and see where things line up. So we'll talk about that. And then the third kind of broad bucket of activity that we'll talk about is registering other types of maps. And here I'm going to use the example of USGS products and state geologic survey products to register to our cave maps. There are many, many other topics that go well beyond the things that we're going to have time to talk about tonight. And if there's sufficient interest in those topics, or we've just run out of time tonight, we can always set up another session and kind of do georeferencing 2.0 and get a little bit more in depth into some of these topics. You know, my goal is just to try to keep it to an hour or so, and that's a good attention span, it seems like, and it's about how long my voice likes to hold out on Zoom, so it seems like a reasonable match. So having said that, one of the things that we need to have is a common definition of what it means to georeference. And all the different software vendors, and there's many different versions of this online. My version of georeferencing is just simply, it's the process of adjusting a map, sketch notes, or some other rasterized data to a set of known coordinates. So the whole concept here is we're going from the known to the unknown. And in doing so, we're able to provide context for information that otherwise would not have any context. And that's something that's actually quite useful because whenever we scan cave notes and we scan a cave map, the computer doesn't know if that's a picture of cave notes or a picture of your cat or your coffee mug. It just doesn't know. And so it's not until we add that additional step of georeferencing that the data really become valuable or come into their own in the context of what we would hope to do with them as cavers, as explorers, as scientists studying caves and karst. So that's our definition. I think it's also helpful to talk about optimal point or control point distribution. And so the term control point refers to a set of points that are known, and then we identify those same set of points on the unknown. And so georeferencing is just a process of saying, this is a point in an unknown space, and here's its equivalent in a known space. And so if I have my cave map here, and I just made up a little line plot, if I have my cave map scanned, and I know that this point on the piece of paper or on the map that I've scanned is in this location on on my GIS, either by coordinates or by some other reference information, GPS location, or something that I've input to the GIS previously, I can just register that point over. And so the optimal strategy for control point distribution is a right triangle. And that's what I'm trying to show here with these solid lines. So the bottom leg and the left vertical leg of this set of control points would be an optimal solution for this set of data. Because if you project out to the fourth point over here, that gives us full coverage of our area of interest. Now, our area of interest might be 2 survey shots, or it might be a scan map of a quad for Mammoth Cave, or some other long cave system. And so all of these things are going to be up for discussion as you go through georeferencing. So georeferencing is going to be one of those areas in GIS where it's kind of half science and half art. And the art part's going to come along with experience. Now, it's okay if we rotate our control points as long as that relative relationship between our control points maintains a right triangle. And we can even lay it over on its side. If it's horizontal K-passage, just rotate the right triangle and so forth. None of this is a big deal. Unfortunately, this almost never happens in the real world. We never have the luxury of having a right triangle. I'll explain probably closer to the end of the talk one scenario where you might have the luxury of a right triangle, but even then it's probably not going to be optimal for you. So, okay, this is optimal. This is kind of a reference point that we want to strive for, but we understand we're probably not going to get there with most of our cave data. So what do? We want to try to avoid worst case scenarios is the real goal. And so worst case scenarios give us a subset of our data or even a fractional part of our data. So here I still maintain the right triangle, but my right triangle's really not in a good position here because I've got so much of my data that's extending out on past the hypotenuse of my triangle. And so whenever I start seeing, and imagine if I, again, draw a bounding box that goes around my whole line plot or my whole sketch, if I've got dashed lines on both sides of that and a third side of that rectangle, I'm in trouble. And I'm probably going to have some difficulty getting a good registration on that data. Likewise, if I have collinear points in a line, I'm not going to get a very good registration, typically speaking. I'll show you some ways that you can try to mitigate that, because the reality, again, is that some caves are just collinear, whether it's survey stations or control points and GPS. Some caves do run in a straight line, especially joint controlled caves, and it's just a fact of life and something that we have to learn how to address, but it's not a good scenario. And if you find yourself with a bunch of collinear points, it might be time to start investigating some other strategies that we could put in place in order to get a better registration on your data set. So that's kind of the best and that's the worst. So what does that leave us with in between? It leaves us actually with quite a few different options. Some of those are quite simple. They allow us to move, scale, and rotate. So the Helmert method is that type of method. And I should also put in a note that some of these registration methods are also available in programs like Illustrator and some of the other drawing programs. So they're not entirely unique to GIS. The unique part in GIS is that you are usually referencing those things to real world coordinates. And that's not the case in a program like Illustrator or Inkscape or anything. There it's a relative registration, not an absolute or physical registration. So here, we now diverge from the idealized right triangle and the worst case collinear models, and now we're going to use some mathematical transformations to adjust our scans or our images that we have. So I mentioned the Helmert method. This allows me to move, scale, and rotate. And this is a good method for 3 points in a registration because you want to move it from wherever the scan's at. Most likely it's going to have coordinates of 0, 0 since it doesn't have any coordinates. So when you plop it into a GIS, it just says, you know, the default is to put all imagery that don't have coordinates at 0, 0. And so that's where you'll find your image. Luckily, we have some tools in GIS that we don't have to go on a scavenger hunt to find that image. But nonetheless, that's where it'll come in. And if you have sketches that are really well drawn to scale, and typically in most cases, this is going to be horizontal caves. If you've got caves that have a lot of up and down drops, those kinds of things where the sketcher is maybe not taking the time to do all the trig in order to plot the shot exactly correctly, this method's probably not going to yield good results in that case. And so here you want sketches that your sketchers are drawing to scale reliably, and that you have, well, another scenario that you could use this is if you have maps with corner coordinates. So this would be like, if you happen to know the quad boundary coordinates for your cave map or your map border, then you could also use Helmert method. But again, that's not as common, especially on old maps. They didn't typically put coordinates on the edges. But if you have that information, or you can develop that information, you may still be able to use the Helmert method. So Helmert is quick and dirty, usually relies on 2 points, one to move, one to scale and rotate. And you can add third point, you can add a fourth point. But one of the things that you have to really understand in georeferencing is that more points are not better. And so there's kind of a myth that if I can just add enough control points, then everything's going to match up. But georeferencing is like balancing cave survey loop closures. And so, you know, in a cave survey program, you would want to distribute that error over the entire loop. And georeferencing is, think about it in kind of a similar way, is do you want to distribute the error across the whole image, or do you want local distribution of distortion that could preserve some areas of the image and make other areas more distorted than they would have been with a simpler transformation algorithm? So what do we do if we don't have a situation where things are really drawn to scale, or some other challenge that's going on with our images? Then we have the polynomial method. So there's, in both QGIS and in ArcGIS Pro, there are 3 methods called polynomial 1, 2, and 3. Polynomial 1 is also known as the affine method. This is I think the default actually in Illustrator, if I'm not mistaken. And one of the characteristics of polynomial 1 is it preserves collinearity. So if you do have control points that are in a line, you're going to hold those points, but the image can still only be scaled, rotated, and translated. You can use this on cave sketch that's mostly drawn to scale. So station to station might look pretty good, but across the whole sketch or across the whole map, it's not, you know, you have accumulating error, that's what it's called. But it's not great if you have long linear passages, because you're going to creep back into the collinearity problems. It works well on winding passages because winding passages more approximate a right triangle than the collinear point distribution. This method is not good at all, really, for large maps. And so if you're trying to georegister large cave maps, it's not a good place to go. Polynomial 2 is same as 1. It adds curvature. That's what I'm trying to show in my little diagrams over here. So polynomial 1, we can move, we can scale, we can rotate. In polynomial 2, we can do all the things we did in polynomial 1, plus we can curve the point distribution. And then polynomial 3 gets into our warping as well as all the things that we're doing in 1 and 2. So whenever you get into polynomial 2, and certainly whenever you get into polynomial 3 transformations, if you've ever added an extra control point in Illustrator and GIS, and it looks like somebody took the sides of your scan and just stretched them apart like you were stretching a big sheet of rubber or something, that's what's happening to it. And so the the program is trying to distribute that error over these large areas, and it's yielding, I think the official term is suboptimal results. So 2 and 3 are good if your points are good, but if your points are junk, then you're going to get junk out of your transformations. There's nothing magic about the polynomial methods that's going to recover something that is just not in good shape. More recently in GIS, they've introduced a spline transformation, also called, in QGIS, it's called a thin plate spline. And this is really, if you want to imagine or looking for an analogy, this would be like putting thumbtacks in your registration points in your map, and then you're distributing error between those thumbtacks. And so this is a method that yields usually favorable results. I'll go through an example and hopefully be able to demonstrate that to you, where we're not getting good results with some of the other methods. Thin plate spline, or the spline method, will be a real nice tool in the toolkit to be able to apply that transformation. This method's not only been around in software for less than, say, 5 or 10 years, so it's still relatively unknown. Certainly if you get out of professional circles and to volunteer communities like ours, you won't find it as common, but it's a really good choice. And in fact, I think over time, you'll see more and more people using it as a default choice on the images that they want to register. So this is a really good choice for images where they may be crossing boundaries, getting close to the edge of the sheet, or maybe the sketching was being done in the mud, in the water, and maybe the sketcher was going a little bit too fast or not paying quite enough attention, or you know, contrary to past science, sketchers are human beings and sometimes they just make mistakes. So this is really going to be the best choice to deal with problem sketch areas where you can isolate the error down to a very localized part of the sketch, and it can also deal more favorably if you really have no option but the collinear control point distribution. So just some things to look at. These slides will be part of the video, and I'll also post the slide deck on with the content, so you'll be able to get back to this as a reference if you want it as well. And then kind of wrapping up, one final thing we need to talk about, and this is related to using GIS coordinates, or I'm sorry, GPS coordinates in GIS. We need to remember where we're working and what that means in terms of the sign for the minus and the plus. And so go all the way back to high school geometry. We've got the equator at 0 on our horizontal. We've got the prime meridian as 0 on our vertical. And so if you're working in North America, if you're working in Mexico, your longitude will be a negative and your latitude will be a positive. So sometimes people get these two coordinates shifted around. So we think about X and Y, but in lat long, we always think about YX. And so we want to make sure that we are getting the right numbers in the right location whenever we import those numbers. Otherwise, we're going to wind up with an inverted control set, and the inversion of XY here and a minus plus is going to put you down here in the Indian Ocean off the coast of Antarctica, probably with your GPS points. So if you find your points showing up down here, that's usually a good sign that you've made a mistake and need to go back and look at the signs you're using or the order that you're using for plotting your GPS points. And then also you should be able to always tell longitude from latitude, because a latitude could never be more than 90 plus or more than 90 minus. So if you see a coordinate in there that's 95, 100, 110, that's a dead giveaway that has to be the longitude. And so you can do some on-the-fly detective work with your GPS data, your coordinate data, to try to figure out where you're at. And also, if you're in the US, you're looking at numbers that are in the 30s and 40s for latitude. Mexico is going to be in the 20s, and then obviously down here, a lot of the work we do in Galapagos is less than a degree from the equator, so you're only dealing in minutes and seconds whenever you get down there. But you can bracket or put some borders around your numbers, and that'll be able to show you some of that information. So let's take a pause there real quick and see if anybody has any questions related before we move into software. Yeah, Brian.
Yeah, I was just thinking if you had for instance, if you just had a GQ, you had a quad and you knew all of the coordinates for those quad boundaries, then what would be the ideal georeferencing system that you would use?
If you have the exact coordinates for the quad boundaries, you can use 3 or 4. I'm actually going to show you an example later on. This is the USGS quad boundaries for a quadrangle, 7.5 minute quadrangle, but these have been converted into UTM coordinates. So they're not lat and long, they're UTM. When you deal with computers, computers don't like degrees, minutes, seconds for the most part. So 2 things you'll want to investigate if you're going to do a lot of this work is either working in UTM coordinates, or if you're in the US, you could also work in state plane coordinates. I don't see very many K projects done in state plane though. So UTM is one option, and then the other option is decimal degrees. And the reason there are 2 options there gets into a conversation about projection of data. So taking curved data on the surface of the Earth and projecting it onto flat computer monitors. So the UTM solution is what's called a rectangular coordinate system that has XY, and the decimal degrees is still a polar, or what's called a geographic coordinate system. It's just being displayed in decimal degrees so that the computer can make sense out of those numbers. So if you have that data so those are examples of good control points. Typically outside of something like quad boundaries, we don't have control data to reference that is as good as what we have with USGS. So a GPS location, for instance, and on a good day is plus or minus 3 meters. And if you've got 5 of those and they're all plus or minus 3 meters, you've got quite a bit of play in your registration system. It's still best available data, but understanding that that's still not anywhere near as accurate as something like a USGS quad boundary corner is useful information whenever you go to trying to make sense out of all this. Does that help?
So but going back to your previous slide where you were talking about either spline or polynomial or even the Helmert, which one would you use as far as those different?
So for a USGS quad boundary, you could use almost any of these. Well, you probably wouldn't use polynomial 2 or 3, but because you have such rigid control, you could use Helmert, polynomial 1, or thin plate spline. Really though, which one should you pick? It's pretty clear which one you should pick.
I would be thinking Helmert, but
Yeah, so you should pick Helmert every time, because all you want to do to that is move, scale, and rotate. All right, so there's no warping, there's no bending that needs to go on because you have the 4 corners and they are defined by coordinates. So don't use something more than what you need for the data that you're registering, because all you're doing is introducing additional error through the transformation, through the algorithm that is being computed against the data set, against your control points. Good question.
As much as I've georeferenced, I just haven't seen that Helmert in Arc anyways, so I was just...
So in Arc, it may go by a slightly different term. I pulled this Helmert term from QGIS, so it may, we'll look when we get there and see if they're using different terminology for that. But you can do move, scale, rotate for sure in Arc. I've done it more times than is probably healthy for anybody to do. Any other quick questions? I think what I'm going to try to do is do several different things inside of one software package, and then we'll bounce over to the other software package and look at its equivalents there. And so I'm going to start off with QGIS here. And we're going to build on some of the things we talked about last week. So if you want to know how we got our vectors from walls from Compass through a shapefile into the software here. I encourage you to go back and watch last week's video, and that'll hopefully show you some of the information that's available, and steps that you can use to get to this point in the game, so to speak. But we have some survey data in here, and we can pan around, zoom in, zoom out, all that good stuff. But one of the things I've done is to add in a survey sheet. So this is just a scanned sketch that we have. And let me make sure, sorry, still managing participants here. And we want to then take this scan of the book, and we want to georeference it to our line plot. And this is an area, I picked a scan in particular that's got a few challenges with it, and it's one of my own scans, so I can pick on myself if I need to. But all of this happens, as when we talked about this last week as well, through plugins in QGIS. And so we can see all of the plugins that are available to us in QGIS, and we can search for plugins. So last week we searched for the map swipe plugin, and this week we're going to come back and search for our georeferencer. So georeferencer is a built-in plugin, and I can see that because instead of having the install plugin that we had last week with map swipe, this time I just see a checkbox, and I can add that in or take it out. So if you watch right up here in my toolbar, when I turn that on, it just adds an icon to the raster toolbar in QGIS. And so that's really all there is to it in order to get the georeferencing tools activated inside of QGIS. So when we've got that and we're happy with that, we can close our plugin window, and now we're ready to georeference. So the way this works, and you have to stick with me here because I'm limited screen real estate, so I'm going to be moving some things around. Let's move this over a little bit. The way georeferencer works in QGIS is you have this window or dialog box that pops up, and we have to choose a raster image that we want to add to the georeferencer. So it's added to our project over here right now, but it's way down there in no man's land. It's way down there at coordinates 0, 0 somewhere. And I'm looking at my coordinates down here at the bottom of the screen, and I can see that that is a UTM coordinate for this part of the world. And that's what I want to register my sketch to. So I open it in the georeferencer window, and I can zoom in and zoom out on that sketch, but this is a different window than my map window here. And so this is kind of a working or a workbench type window, not a window where I can view the adjusted data. So that's still going to happen in the map view, but right now what we have to do is that process of saying, okay, A73 on the sketch is right here, and it's right here on the line plot, and make those associations however many times are necessary in order to get our best results. Now, the settings pulled down on this dialog box is where you set all your different methods that you might want to use. So here's Helmert, all the polynomial methods. I mentioned the thin plate spline. You can see there's one called linear, one called projective in QGIS anyway. Just stay away from these. These are not going to be any help to the kind of work that you would do in caving. They're going to give you poor results, and it's just not work. I mean, you're obviously welcome to play around with them, but what I'm trying to cover here are things that are practical and hopefully usable to you on your cave work. So we're going to start with Helmert. So we pick our transformation, and then we have to also say, okay, where do we want to save that? So I'm going to save it off to the same folder, and we'll just give it a name. And so that's all the behind the scenes things that are going to happen whenever we do our georegistering. And then I start adding control points, and my add point dialog box is going to be right here. So I say, okay, I need to pick, here's A75. So I pick that, and I get this map coordinate box showing up. If I know the X and Y coordinate of of A75, I can type it in right here, but I'm never going to know that typically. So what I want to do is say, I want to grab that point from the map canvas, and then I can come over and say, okay, A75 is right here. Now, without zooming in and panning around, it's going to be difficult for me to find A75 exactly. And so one of the things that would be really nice to be able to do here is to snap to my stations so I don't have to guess at that. And so I'm going to come in and open up my snapping toolbar in QGIS, which has the little magnet here. And I'm going to turn that on. And whenever I turn that on, we'll see different behavior. So let's dock this so we still have access to it. And let's come back and add our control point in again. So we got our choose from map canvas. And now you can see when my cursor gets close to the station, it snaps to the station. So the guesswork's all gone. So I add that control point in, and then I'm going to say, okay, I need to add another control point. So there's my first control point. And so now A74 looks like it's over here. Can zoom in a little bit. Pick that one from the map frame. Okay. And then that adds a second control point. And then let's see if we can find one more. I'm going to come down here to, what have we got here? A72, which is right here. So I'll add A72. So that's going to be right in this area from the sketch, and then right here on my line plot. So now I have 3 control points. If I want to run that particular transformation, I hit the play button here to start the georeferencing. And that georeferencing is complete. And using the browser that we discussed last week, I should be able to go find my file that I had created, drop that into my project, and now I can see that georeference file on my map. And I'm going to move our georeferencer out just for a little bit. So let's look at what we got. Helmert, we know we can move, we can scale, we can rotate, but we're doing that globally to the image. So everything on the image is having that transformation applied. So A75, close. I'm not on it though. You know, so the distance in this grid is 1 meter by 2 meters. So I'm a good 1.5 meters off my control point, and that's one that I defined. A74, I'm missing it by even a little bit more. 73, forget about it. 72 is good, and then I'm not even inside the walls of the cave as it was sketched for 71. So we've got some challenges here. And again, this may be because the cave has a lot of up and down in it, and I just didn't do the trig as well as I thought I did. It might be because this particular sketch crosses the binding between 2 pages. This is a bound book, but you can have these problems. I've seen lots of sketches that get really close to the 3-ring binder on the yellow right in the reins that cause problems with sketch. When sketchers get tired and they don't want to take the pages out, all those kinds of things happen. And so what we're trying to do is figure out how we can get a best result out of that. And so here, I don't think anybody would say this is the best result. What we could do with Helmert, or even the affine method of polynomial 1, is we could register it for A72 to 73. We could do the same thing for 73 to 74 and on down the line. We would get pretty good results that way, but that's super time consuming, and you wind up with a lot of extra scans and files that you have to manage. So I think we can do better than that for this particular stretch of cave. So let's come back to our georeferencing, and let's say that we want to remove these points. So we're going to delete our control points that we had on this particular scan. Now, some people, whenever they're doing this type of work, one of the things that they want to do before they do anything else is rotate the scan to north. And you can see north is to the left here on this scan. Certainly you can do that, but there's really no need to do that. If you can orient yourself, so this is, you know, whatever scanner this was put on, scanned in portrait mode, you could rotate this in Acrobat, or whatever your image software is with your scanner. You can do it in GIS. You can do it with free utilities online, but it's just extra work. And if you're doing this a lot over and over again, that's probably steps that you can avoid if you want to. So let's take this now and change our transformation setting. And in the interest of time, we could kind of tinker around with some of these. Maybe I'll do a different one in Arc. But let's move down to the thin plate spline, and let's call this something different. And now let's add our control points in. And so I'm going to say, okay, come back to add points. I'm going to use 75, choose that from the map frame. It's right there. I'm going to say, here's 74, map frame right there. Then we're going to go down to 73. And you don't have to do all of these. I'm just doing it for demonstration right here to show what you can get out of this. So I have 72, 71 here, and these points are really close together, but I'm going to go ahead and use both of them to see what we get. So 72. And then let's go with 71. Okay, so now we've got a different method, but we've also got a lot more control points. So we're up to 5 control points on one sketch. And so let's see what we get out of this transformation. So that's been completed. Move this out of the way. Back to our browser. Here's our spline image. We'll add that into our file. And so you can see some different things have happened here that were not happening on the Helmert method. So not only are we scaling and rotating, but we're also tilting. Imagine that the top right-hand corner of the book is tilted away from you a little bit. And so these are things that are trying to reconcile all of this information. Let's move our vectors up above, and so we can see it. We can zoom in and say, this again, this is our thumbtack method that I mentioned. So we should be right on all of our control points, and all those control points are stations on this sketch. Now I've got a station up here that's right on the edge. I could add that into the mix. I might want to check the other book first, or the other page of the continuing survey, see if we picked it up coming back the other way. But this is quite a bit of sketch typically that you would want to hang, not without a control point. And so we can come back into GeoReferencer, add that control point, rerun the transformation, see if we get a better result out of that. But I'd say all of these results are pretty darn good. So my cave is my survey is now inside the walls that were drawn on the sketch. We're getting more error distributed across from A72 to 73 simply because this is where it crosses the spine of the book and there's some irregularity there. But we've got really nice sketch on the areas that are on the full page as well. So again, there's some trial and error here. You can see A70 is not hitting exactly. We could fix that again with another control point. So we could have 7 control points potentially on this page. But these are things that you can add into your cave map, see how it lines up with any walls. You can change I was playing around with this earlier. A lot of people think you can't do like these glow effects and things within your within GIS, but you can. You have control of all the lines and everything, so you could draft your cave that way as well. So that's adding a cave sketch into QGIS and registering it to some known control points. These control points were derived through Cave Survey. Any quick questions on that before we go on to our next topic? So the other thing I wanted to look at in QGIS is the ability to register a cave map to a different location. And so I'm going to save this project, and then we're going to look at a map registration project that I set up. And so in this project, what we're looking at is a made up GPS location. So imagine that somebody's gone out and GPS the entrance to this cave, and it's right underneath this tree in central Illinois. Maybe there are caves there, but they're going to be under about 500 feet of glacial till, I think. But we have now a cave map of this cave that was drawn back in the 60s. So this cave was found during the golden age of caving, and now we want to register that old cave map and scale it appropriately on GIS. So what I need to do is to come find my scan. So I'm going to come up to our cave map. Let's see here, right here. And we're going to add that into our project. Now this type of registering is distinctly different from the type of registering we went through a while ago. And in the registration we had a while ago, we had the ability to identify known control points. Here we have one point. And even with the simplest transformation methods, you can't georeference a map with one point. And so we have to figure something else out. We have to do something else in order to make that possible. And so we have our map here. And the next thing I'm going to do is come back to my plugins, go to my manage install plugins. And the ones that are the one I want to look at is, let's see here. We've got our georeferencer. Let me just search. Is one called Freehand Raster Georeferencer. So this is a new plugin for us. We haven't discussed this one before. I'm going to add that to my project, and that adds this whole toolbar right here. So I've got my map added, and now I want to be able to load a map and work with it. So again, I loaded my map, but it's way off in the corner down there at 0, 0, not helping me out at all. And so we're going to add a new map here, which is our cave map. And that's been added to our project. And now we want to take, pay attention to what I'm doing. And now we want to take that map and do something with it. We want to register it. So I have tools on this toolbar. Let's just move this out here where we can see it a little bit easier, hopefully. So we just added a tool. We can also move that raster around. So I can take that and move it from point A to point B. So this is my move. If I know where the entrance is, I can move it over to my GPS point. But my map is still not going to be the right scale. It's not going to be something that is useful to me in correcting the overlay. The only piece of information that I really have on this map that's of any use to me is the scale bar over here. And so I can come in and look at that scale bar and say, okay, I know that if this map was really drawn to scale, that this cave, or this distance from -50 to 450 is 500 feet, or it should be 500 feet. And so to get the map to the right scale, what I'd need to do is figure out how long is that line now, and what is the scale factor that would be needed to make that line 500 feet long. And then we can use our geo-registering tools here in freehand mode and say, okay, set that line to be that length. And so that's what I'm going to work on next here. So let's look for our 500-foot line. So I've drawn a line in here that's 500 feet long somewhere. Actually, you know what? It might be gone. Let's see. Yeah, I made it as a temporary layer, so it's not on there anymore. So we would set our line to be 500 feet long, or if you don't want to draw the line, one of the things that you can do is measure on your map and come up with something that is the same distance. So it's maybe the distance from this road over to this road, the edge of this woods, anything like that is going to work for you as well in terms of being able to understand, you know, the relationship between the two sets of data. So let's see here. We want to measure a line, and if we measure right now, get it to where we can all see what's going on here. Measure our line. So the distance currently from right here to right here is 250 feet. Now this is never going to be exact because this information was drawn with an ink set back, you know, with the aught or triple aught pen or something like that. And so even if you had the original, it would be close to 450, but the reality is even these little tick marks are probably like 5 feet wide on this map.
You're in meters right now, Aaron, just letting you know.
Oh, sorry. Let's go back over to feet. So we're at 874 feet. So what I would want to do, and I don't really have a good way to do this on the screen, but you can do it if you want to follow along, is that you want to divide 500, which is what it should be, by, you know, let's just call it 875. And our scale factor for this map is 0.57. So we need to reduce this map by, it needs to be 0.57 times as big as it is right now in order to be able to correctly show that map on the screen. And I'll go through this again in ArcMap. So I'm not going to do it twice here, but what I do have is I think the completed map. Hopefully it's still on here. Oh shoot, this is still, so you can, if you look at my coordinates, it's down here. It didn't store my transformation. All right, I may have to fix this video and post it online. For some reason, it didn't stick with the location it was supposed to be in. But what we would see here is the map would be overlaid on top of these fields right here, and then that would give me the ability to go out and look up for leads or you know, look for springs or whatever it is that I'm interested in moving on. Or if this field is up for development for some sort of industrial park or subdivision or something, you would be able to see the cave where it runs underneath all this. And hopefully we can see that in ArcGIS. All right, let's transition then from QGIS over to Pro and talk about registering our geology map. And then I've got our same GPS coordinate up here for the cave, so we'll work out the cave here as well. So Arc Pro is a very different interface than QGIS. Don't be intimidated by it. It's just different. It's not, you know, there's nothing magical about it. In fact, some people like the QGIS interface better because for the current version of ArcGIS Pro and really the last several versions, Esri's moved to this ribbon interface. If you use Microsoft Office products a lot, you've seen this, but it allows you to pack a lot of pull downs and settings and stuff into one area, but it's also easy to lose track of things, and not everybody's comfortable with it. So let's add in some of our data layers here. So I'm going to go and I've added a base map like we did last week. I've added my point corners in GIS. I said I'd show you how that happened. If we go to edit and we want to create a new point corner, if I know exactly what that point corner is, I can move my cursor over and say, okay, we're gonna make point corners. And whenever I get on the screen, if I hit the F6 button, a dialog box will pop up, and I can type in decimal degrees. I can type in degrees, minutes, seconds, and it'll do the conversion for me. Here's my UTM. So you just put in whatever your coordinate values are, you hit enter, and that point is then added into your map. If you want to add the text file like I showed earlier, the way you would do that is to use your map, add data, only you want to add XY point data. And that'll allow you to map out a set of coordinates. I touched on this last week. It's sort of what you're doing whenever you do GPX coordinates off your GPS as well. But that's how we get our coordinates for our control points. And let's say I went online and found through the Illinois Geologic Survey, I want to add in some topo map and then some geology map. So I'll come to my folder, and I have, for this quad, a DRG file, if you remember DRG files. Now, this is the way it comes from the state. And so this is a good, they're already georeferenced from this clearinghouse whenever you get it. And so this is a good check where you can then see, you know, how well did I do on my control points? And they better be pretty darn close, because these were keyed in using these coordinates on the sides of the map. So, you know, there shouldn't be any discrepancy with those coordinates in the corners of the map that's been properly georeferenced from the geologic survey. So the other piece of information, though, that I downloaded was some work that had been done by geologists to map out the geology of this quad. And so on the Ames quad, whenever you download the file, you get this PDF. And so this is all the surface geology. Here's the column and all the notes and things. What's really handy about this, and this is pretty universal throughout the United States anyway, but what's really handy about this is that they were mapped on the 7.5 minute quadrangle. So those four corners are the same four corners that we have in GIS. Now, what's not as helpful to me is all this extra information on the geology map. Yes, I want to be able to look at that, but for the purposes of my overlay, I'd want to crop that image down. So the only steps here that I'm not showing how to do is to open this up in Photoshop and Adobe Acrobat or something, save it out as a JPEG, as a TIFF file, and then crop that down, you know, is the next step to that. And so once you've done those two steps, then you can add data and you'll have your geology map. Now in ARC, I get this message, hopefully you can see it up in the right-hand corner. It says unknown coordinate system. And from the unknown coordinate system, that's telling me that all of that information is down there at 0, 0. And it's not being shown on the map right now because it doesn't know where it exists in the world. And so what I need to be able to do next is to take this file and georeference it. In ArcGIS Pro, they moved the georeferencing tools. Those are all located under the imagery tab on the ribbon interface. And you'll see a big icon here that says georeference. And that throws you into georeference mode for ArcGIS. And so we want to be able to take our data now and first of all, bring it onto the screen and then to set up our control points. So I'll go to the georeference, and the first thing I want to do is take that data layer and I want to fit it to the display. Now, the goal isn't to be perfect here, it's just to get in the ballpark. You can see right now it's larger than it needs to be. It's shifted over a little bit because it's larger, but I've got icons that allow me to move and take that map and move it off to the side if I want to, move it down. But it's also become translucent so I can see what's going on underneath it. And what I'll typically do is just pick one of my points to start at. So let's look at this upper left-hand corner and get it relatively close here. Because the next thing that I want to do is to zoom in on that so I can be sure that I get a better representation of the corner of my unknown coordinate map, or my geology map in this case, and then I want to register that to my known coordinate here on the corner. And much in the same way that we would do it in QGIS, there's an icon that says add control points. And this tool allows me to say, okay, I want to take this point and I want to, I want to take it from here and I want to put it over to this target. Now I've got the same kind of problem going on here, is that I'm not snapping to my points. So depending on my scale, I may either be okay with that and I can add that control point, which is just a move now. That first point, remember, just moves us. But then I can come in and turn on my snapping in ArcGIS as well if I want to be sure that I'm snapping to all of my points that I have on my map. So let's come back to, this is one I always forget about. Is it edit? I can't remember where they put the snapping toolbar in their new version. Somebody knows where the snap bar is, type it in the chat window.
I thought I saw it under edit, just below the cursor to the left.
Ah, thank you very much, Scott. And so, yeah, we want to turn snapping on, and that'll allow us to snap to key points whenever we set our control points. So in back to our imagery and our georeference, if I want to look at my transformation kind of on the fly, aha, here's some of that same kind of terminology that we had. And so it looks like the Helmert method is being called the similarity polynomial method in ArcGIS Pro, back to an earlier question. And so from here, what we want to be able to do is to review our transformation method. The default in Pro is that first order polynomial, or the affine method that we talked about. And this is the, as I said, the same method that's being used in Illustrator a lot these days. But you'll see down here that we've also got a spline method. But in Arc, it's telling us a spline method requires at least 10 control points. We don't have that. And so we said, anyway, on a geology map like this, our similarity or Helmert method is the method of choice. So what we'll need to do is now come in, and there's shortcut key-ins and stuff to do all this as well. I'm trying to do it all on the screen, so I'm not doing something, you know, off to the side that you can't see. Our control point is here, but our point is way over here. And so if I want to be on the screen, what I'll want to do is add my control point here, and then yeah, from here, and then I'll want to either scroll over, pan over, or somehow get over to my other control point. So what's really nice here is you can use your pan tools and so forth while you're still in your georeference toolbox. So you can add these 4 points in, and then whenever you come back to transform, so I'm going to add in this point over to here. And so now we've scaled down, and then pan up a little bit. I can see I'm pretty well on, and that's because I do have good geometry. As I said, if we zoom in real close though, we'll see that these are off by a little bit. And in that third point that we talked about earlier, we'll fix things up. So I want to go from this point up to my map corner here. So now I'm right on, and if the map was drawn and scaled properly, we should also be able to see that the fourth point over here is right on. I'm not going to be exactly on here because I didn't snap up there to my first control point. I can add another control point here to make up for that, but that's probably not the right way to solve this problem. It's to go back and snap to your corners more accurately than what I did just now. So I can take that point and force it over to that location. But you can see I've still got some little deviation here. When you snap to your points, you won't have that deviation anymore. So once we've done all of that, now we can still use the underlying USGS map if we want to, But we can also, oh, don't want to do that. Let's come back to our pan tool. We can use our map swipe. We can do a translucency on this. We could overlay cave passage on this and so forth if we wanted to better understand the relationships between the geology and the cave passage or sinkholes and stuff. So on this particular map, the reason it's important is everything over here in yellow and the greens and stuff is all on the edge of the karst. And so the karst is all off to the west from here. So that's how we would register a geology map or a USGS map or anything that had defined coordinate pairs on the side. Need to set up our control points. We can key them in, read them from a text file, and then we can also register to that set of points and use a crop down PDF in this case to bring that data into GIS. So the next thing that I want to show here is to take us, let's turn off some of these layers and let's add in, we're going to close this and not save that. But we're going to add a couple more layers here, and I'll show you how you can take old aerial photos and register those to your maps. So we're going to add some more data, and that data is all going to come to us from the same folder. So let's grab, let's see. Oh, that's not what I want. We want this map. So here's another USGS map, and the other piece of information that I'm going to add here, which also came from the Illinois State survey, is going to be this map, which is a old 1930s aerial photo of the same area. So here we've got modern day imagery, satellite imagery, and here we've got an old contact print. And so the way you do this is similar to the way that we registered the other map, except we don't have the luxury of real control points. And so the way this map was registered was still using the same exact workflow, except instead of snapping to places, what you're going to need to do is find features that were there during the date of the photo when it was taken that are still there in the modern day world. So I keyed on like this road intersection, anywhere that you get a T road intersection of any kind that's been around and not new development. And again, the thing that you're after here is to spread those control points not in one little area, but throughout the image. The one caveat that I'll say to that on these contact prints that were taken out of airplanes is that you get parallax from the lens. So don't get too far to the edge, because there's a lot of curvature out here on this data. You want to stay in the sweet spot of the image, because that's all that's really supposed to be used off that image anyway. So the end result, though, can be quite nice, and that's what I want to show you here, is that we can take, let's take our TIFF file and turn that off, and let's come to our map in GIS, and you can see, let's zoom in. So here's the modern day version of this interchange. And if we turn that image back on, you can see that that lines up pretty well. You can also see how the forests around the sinkholes in this karst area are changing over the last 100 years. So I think this photo is from the 30s, something along those lines. And we can look at, you know, all these kinds of things now that this data is all georeferenced. We can even overlay this on top of with our cave data. So, you know, if you have a report from an old newspaper or something that says, oh, there was a cave over here on the Jones farm, then you can go back, and if you've got some information that allows you to plot out where the Jones farm is, you can see what the ground looked like back during that particular period of time. So it's pretty handy, pretty powerful to see change over time, not only in caving, but I've also used this for work I've done with like land use management. How much of the area was forested before mechanized farming, before they used tractors. So all this would have been farmed with horse teams, steer teams, ox teams. They still use plows and stuff, but all pulled by animals. And then, of course, all of this now is being farmed with tractors and large planters and discs and stuff like that. So what's happening to our karst and our land use areas over karst over time? So this is an extreme example. There's other photos from, say, the 50s or the 70s, and you could stack all these things up together and see how things are changing. So that's a really powerful way to use georeferencing as well as with historical data. So let's come back then to our last step here that I want to cover, and I realize I'm a little bit over time, but stick with me if you would. We're going to come back up to our GPS location, and we're going to add back in our GPS map. And so what we want to go for is the difference between where we were at before in QGIS, and then this is an example of like a final map where we've taken the cave entrance and georeferenced it to our GPS, and then we've also changed. If we pan over here and we use the measure tool in ArcGIS, it's trying to hide out here, then we can measure from our 0 or -50 point and measure down to 450, and that's going to put us right at 500 feet. So this is a properly referenced cave map based on the information we have. The only thing additional that I could do to this map to make it better, and I was contemplating this, but I didn't do anything with it, is I noticed that the north arrow is rotated. So really, to use this in GIS, what I'd want to do now that I have the proper scale is come back to georeference and use my scale tool right here. So let's come to our georeference. I'd use my scale tool, and that would allow me then to rotate by a scale or rotate by a fixed amount if I want to. So I could allow for this 4.5 degrees of declination. So how did I get from the map that we were using in QGIS all the way to this step? And that's the thing that I want to try to finish with here if it'll be cooperative. So I'll need to add my unregistered map back in. So let's go back to our folder where we were storing that information. And it's way down there at 0, 0. I know in ArcMap what I need to do next is start up my georeferencing. And I need to fit that to my display. So there's our mystery cave map. We talked about we can move it around if that's what I want to do. But I have to solve this scaling issue somehow. So let's take a look at that. We'll come back to measure. And we want to measure from here to here. And it looks about the same as last time, doesn't it? So we're going to call that 840. Let's just call it 850. We need to do our calculator math. So the math I'm doing on my calculator is 500, which is the real length, divided by the current length, which we have is 850. And if my math is correct on that, I come out with a 0.58 scale factor. So I would want to then come back to georeference, come to my scale, and the thing about the scale here is that it wants to do it dynamically in ArcGIS, just meaning pick 2 points and I'll scale between those. But if you click on the screen and then hit the letter A as a shortcut, this little rescale window will pop open. And in this window then, right now it's at 1. Then we can say, okay, scale that by 0.58 in the X, by 0.58 in the Y, and process that. So that map's then been rescaled, And if we zoom out, we can see it jumped over here. It's a little bit more than half as big now. So within georeference, my last thing that I need to do with that map is to move it back to the GPS location. And so I'll get it generally right. And then let's say for this exercise, I've been using this little side passage as the entrance. So I want to move that over. I didn't quite get my GPS on there, so let's pan over a little bit. Here's my GPS, back to georeference, back to move, and then I can take that little entrance and put it in the correct place. When I'm happy with all that, then I can close my georeferencing. Let's save it, close it, and now I have a properly georeferenced map. And this is, that last step was just symbology, which we went over a little bit last week, and I can go over more at a different time, but to just do a double check and make sure, you know, a sanity check here. The last thing that we'll want to do is measure our new scale bar and make sure it's what we think it should be. So this is the what I like to call the critical thinking part of all of this. But we want to, you know, measure from our 50 out here to our 450, and it looks like my scale factor is off a little bit. Probably should have done 0.6. We should be right at our 450 length there. So that's a lot, and I was afraid that it was going to be a lot, just because there's a lot of different moving pieces in georeferencing. I would encourage you not to try to tackle it all at once, but rather to dissect it and digest it and its individual components. There's no one thing here that we did tonight that's particularly difficult, but there are a lot of moving pieces. I realize that. And so I think in the interest of time, I'm going to wrap up the how-to section here, and we can come back to our conversation in Q&A if anybody has any questions or wants to see something in particular that that we did or that we want to cover again.